All right, now we're on to trig equations, which refers to my favorite part of the year. The first thing that's good to have in front of you are the three Pythagorean identities. One that you have memorized 100% all the time in your sleep is sine squared plus cosine squared equals 1. Remember, those have to be squared. Have to be squared. So, you guys know I'm not all about memorization, but I do like to be able to find my equations when I need them, of course. So, we need to be able to take sine squared plus cosine squared equals 1 and find the Pythagorean identity with tangent squared in it, and find the Pythagorean identity with cotangent squared in it. And we can do that by division. So I'm going to take that main identity that we have memorized, and any legal algebra I do to it is also an identity. And remember, an identity just means it's always true. So it's true no matter what value of x you put in there. So if I start with sine squared plus cosine squared equals 1, the way to get the identity with secant squared in it is to divide everything by cosine squared. If I want secant squared, then I want 1 over cosine squared. If I'm going to divide by cosine squared there, I need to divide everywhere. Remember, this is legal algebra that we're doing. So sine squared divided by cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So there's the second Pythagorean identity. Again, any algebra that we do to these that is legal holds for is also an identity and holds no matter what. All right, I'm going to start with, again, sine squared plus cosine squared equals 1. And since I divided by cosine squared already, I'm going to divide by sine squared now. And that's going to give me 1 plus cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. The other way that I remember that is that the cos go together. So cotangent squared goes with cosecant squared, and so then tangent squared goes with secant squared. All right, now that we have those identities, we can use them. This number 21, we're going to solve for x. We need to get the equation for all solutions. And we're going to need to start by finding a common denominator. But if you're working the packet in order, finding a common denominator right now should not be such a big deal. So you've already done the rational expressions and equations part of the group. If I'm going to find a common denominator, I'm going to multiply my first fraction by cosine of x over itself. That's just the denominator that it doesn't have, the denominator that it needs. And I'm going to multiply my second fraction by 1 minus sine of x. So my new denominator is cosine of x times 1 minus sine of x. And my numerator is cosine times cosine, here, which is cosine squared, plus, and then I need to multiply this out. And by multiplying it out, I mean FOIL. So go ahead and try to get a step or two ahead of me. Pause the video and FOIL out 1 minus sine x times 1 minus sine x. And I'll meet you in a couple steps. All right, so 1 times 1 is 1. Hopefully you're checking your work at this point. 1 times negative sine is negative sine of x. Negative sine of x times 1 is negative sine of x. And negative sine times negative sine is positive sine squared. Not to make you worry if you're a worrier, but a lot is writing on the fact that our signs, S-I-G-N-S, our positives and negatives are correct here. So this is a really good time, especially if you have a little time to double check your work, to pause and make sure you have those middle terms both negative, that you did sine times sine is positive sine squared. That's really important. And now I'm just going to combine my like terms. So just combining those negative signs. Some of you are probably already flying with solving the rest of this because you've seen a couple steps that you're going to take. If not, sometimes it's easier to see the next step if you put your squares together, because sine squared plus cosine squared is 1. Now, the fact that you have a positive sine squared and a positive cosine squared is important here, so you want to make sure that that is the case. So here I'm going to change my sine squared plus cosine squared to 1. If you're thinking to yourself, man, I would have a hard time seeing that, just when you're working through any problem like this, you want to look for those Pythagorean identities, and you want to look for those squares. So like the closer you can put your squares together, I think the easier it is to see whether there's a relationship or not, or work with that relationship. All right, we're just a couple steps away here. 1 plus 1 is 2. And remember, this is an equation, not a proof. So don't get worked up. We're not trying to match the 2. We're solving for x. I have 2 minus 2 sine of x on top and 1 minus sine of x on the bottom. I am going to need to get rid of one of my variables here so that I can solve for x. So I'm going to do that by factoring out that 2. And then I can cancel my 1 minus sine of x. Now I have 2 over cosine of x equals 2 over 1. You can cross multiply and divide. 2 times 1, 2 times cosine. So 1 equals cosine of x. And don't forget, we're not solving for cosine, we're solving for x. So what our question there is, where is cosine 1? And on the unit circle, cosine is 1 at 0 and 2 pi. Since those are 2 pi apart to the equation for all solutions, you would do 0 plus 2 pi k. That's a really long one. If you can do that, I think you're in really good shape on the test. That's a good example for pretty much the longest problem I could ask.